Thanks, Adrian. I'm delighted to be here today and tell you a little bit about how renewables and energy efficiency can be used at the exploration stage, and provide you with an example, a case history from our Nechalacho rare earth elements project in the Northwest Territories. So I think it's probably appropriate that I'm on the front end here today, in that exploration is on the front end of the mining cycle. And most people think of the use of renewables at the mine production stage, and maybe you're not aware that they can now be applied at the exploration stage as well to lots of benefit in terms of cost reduction, but as I'll show you, more importantly in terms of introducing that whole culture of energy efficiency into the company and introducing thoughts and innovation about how renewables and energy efficiency can be applied later on at the mine development stage, and start to create some of those ideas early on, even while you're doing the initial exploration. Remind you not to rely on any of the forward-looking statements I'll make today. And a little bit of background on who we are. We are a specialty minerals and metals company, and we have been focused on those niche market commodities that are increasingly important in clean technology and renewables, actually, such as rare earth elements and lithium, as the Parliamentary Secretary reminded us earlier about, as critical elements to that technology. And it occurred to me early on, when we kind of adopted this focus on these critical materials, that it really didn't make a lot of sense to be looking at producing materials for clean technology in an unclean way. And so we decided over 10 years ago to build sustainability into the culture of the company. And while we don't get a lot of recognition for it in the capital markets, we think it is the way of the future, and it does help us in terms of building relationships with our potential customers in the clean tech sector going forward. And we actually have 3 such projects now at the advanced stage. Our Nechalacho project in Northwest Territories is what I want to provide the example from today, but we're already looking at how to implement energy efficiency and renewables on our other projects, our Separation Rapids lithium project in Ontario, and our East Kemptville tin indium gallium germanium project in Nova Scotia. So when I say that we've integrated sustainability into the corporate culture of the company, I'm not just saying we're talking about it, we're actually doing it. We are one of the very few junior companies that has been producing an annual GRI compliant sustainability report going back to 2011, actually. We've been doing it for 5 years now. And why do we do that? It's part of the culture of the company now, and as I said earlier, with these materials, you have to build customer relationships, and often you're talking to consumers, potential future customers that are in the clean tech sector. And if you can align your operating philosophy with theirs, which is to create a sustainable culture, and they like to audit their supply chains back to the source of the raw materials and make sure they're produced in a sustainable way, you're better aligning your future business with theirs and creating opportunities to serve their needs. And another big factor is these days, social license is probably the biggest risk factor that mineral developers face in developing a new project anywhere in the world. And adopting this culture does reduce social license risk. There's no doubt about it. And lastly, as I said earlier, it does create a culture of high performance in CSR within the company that translates into other aspects of it, such as thinking about how you can improve on energy efficiency even at the exploration stage. And everyone knows mining is a very energy-intensive industry. It takes a lot of energy to crush and grind rocks. So there's a lot of benefits in being able to come up with creative ways to reduce your reliance on fossil fuels because of that energy, and introducing renewables now can already decrease your costs some 10 to 15% at remote sites. And obviously that's going to improve with time. And as you introduce that, you start getting more and more creative thinking at those sites in terms of how you can further improve on that. We tend to think a lot about how that can be improved at operating mine sites. Don't think so much about it at the exploration stage. But, and that's because I guess at the exploration stage you're not consuming the vast amounts of energy you are when you're in production. But there are opportunities there too. And so looking at a typical camp, this is a picture from our Nechalacho camp, and we would typically rely on a diesel generator, produce power for the camp. And it's not done very efficiently. It's not done very efficiently at all, actually. You have to deliver that fuel in small quantities over very long distances, so it adds greatly to the cost of getting it there. These camps are typically only operated for short periods of time, a very intense activity, by groups of people that are there for one single purpose, and that's to collect a whole lot of data as quickly as they can to understand whether there's potential for an economic mineral resource there. So they're really focused on that, and they don't tend to pay a lot of attention to the costs of running the camp. It's just, let's get in there and get going and get the job done, and don't worry about what the costs to run that camp. Well, once the camp gets bigger, the costs do get to be fairly significant, so it does become worthwhile to start to look at that if you're there for the longer term and that project advances to the development stage. So that's kind of what the culture of the industry has been, and because we had already adopted that culture, our people, led by Bill Mercer, who did most of the work on this, started to look at how we could improve energy efficiency in this camp, at this remote camp at the exploration stage. Oh. And that was partly by just looking at how much we were spending on diesel fuel. It was an enormous amount of money, actually. We were doing quite a lot of drilling there and spent over $2 million on diesel fuel over 4 years at an average cost of over $3 a liter. So a very significant cost. What you might think is that most of that was related to fuel for the drill. Actually, it wasn't. It was close to 50-50 between the drill and the camp. And if you're operating in a northern climate like we were during those cold winter months, you burn a lot of diesel fuel to heat tents and run the camp, and it's a surprisingly big component of the total diesel requirement. So that gave us plenty of motivation to see if we could try to reduce those costs. And there were some obvious ways to go. We looked at installing renewables early on. Solar panels are the easiest way to go, and we did that. And they're simple to install, are relatively low maintenance compared to wind anyway. Then you have to have an energy storage system, and that's a really key part. It allows you to make better use of the renewables, plus make better use of the generator, the diesel generator that's already there and you need to continue to use. And then the other thing we really looked at carefully was tent heating. That was where we found a huge amount of inefficiency that could be improved on. And we were able to do so through some technology there as well. So the solar panel solution involved these two sharp 170-watt modules installed at a cost of about $2,800 in 2013. When you add in all the extra equipment and labor required to get them fully installed, you bump that cost up by another $1,400. So it wasn't cheap then, but the good news is that the cost of these solar panels is coming down very quickly. And Bill did some homework on what it would have cost us this year to do it, and estimated that that cost would be down to $1,900 for those panels, and actually produce more power than they would have at that time. So the change is very rapid there, and even if it wasn't really efficient then, it's getting better and better all the time. And then the energy storage system we used was relatively new at the time, but involved the use of 8 lead-acid batteries, 6-volt batteries connected in series. They were fairly expensive, $1,500 each, $12,000 in total cost for that. Then we had to add an inverter in at an additional cost of $16,000. Then we add in the cost for installing, labor, transportation, and ended up being close to a $45,000 number to install that energy storage system. So it was a fairly significant investment. But even for this, using the same technology now, these costs have come down a fair bit according to Bill's research, and could probably do it for about $10,000 less now than we could then, using a similar technology. But help is on the way, actually. The lithium-ion battery is coming along real fast. Everyone hears about how it's being adopted in electric vehicles. It's also coming along very quickly as an energy storage solution in the home to reduce reliance on the grid. And these same systems can now be used in remote camps to allow for an energy storage solution and use solar and create more energy efficiency in a remote site. The Powerwall 2 is one of Tesla's products. They've already got to the 2nd generation of these. No doubt there will be more as they continue to refine that technology and improve its energy density and reduce its costs. But this is already a much better looking solution to energy storage than what we looked at with that system we employed in 2013. It's much smaller, lighter, easier to transport, and it reduces the cost just compared to what we were doing by some 25 to 30%. It's easier to install and includes the inverter in the whole system, so much simpler. Can be moved to another camp when you're done. It becomes an asset you can move around or even resold if you don't intend to reuse it. So a much more attractive alternative to the original system that's come along in relatively few years, and no doubt we'll see improvements on this going forward too. Get this to advance here. Oh, there we go. Too far. Where should I point this for maximum efficiency here? Talk about inefficient. There we go. So does solar make sense? At that time, it was giving us a little bit of an improvement on our costs. We were averaging about 80 cents a kilowatt hour for diesel energy. Bringing in the solar as a component of it reduced it a few pennies. But Bill estimates that even by 2016, it would have come down to to about 50 cents there today. So as these get more efficient, the costs are coming down. And this is a very powerful trend. You've seen these graphs probably in many other circumstances, showing how the cost of PVs and solar panels have come down quite dramatically over the years, and even over the last 10 years on an installed basis keep dropping and are continuing to drop. So this is going to become a more and more attractive solution going forward for all sorts of applications, no doubt about it. Now, coming back to heating, as I was mentioning at the start, this was one area where we found a huge opportunity. This thing on the right is your Dinosaur Coal Classic tent heater. Burned a lot of diesel fuel, basically had one little dial on it. It was either cold, hot, really hot, or extremely hot. And difficult to really regulate that. Consequently, it burned a lot of fuel. It was very expensive to operate, even if it wasn't all that expensive to buy. And almost impossible to control it. Plus, these things got pretty hot, and they actually represent a safety risk in the tent. If you trip and fall against one of those, you can get pretty seriously burned, and we actually had an incident of that happen in our camp, and that was another motivation for looking at alternatives, was the fact that they're not only inefficient, but actually dangerous if you're not careful around them. Because they're inefficient too, they also encouraged people to bring in their own little electric heaters and plug them in, and this didn't create any efficiency either, actually. They burned a lot of power as well. So the solution that we came up with, Bill found these diesel heaters, and while they use diesel, they use it a whole lot more efficiently than the traditional ones do, and greatly reduce the consumption. And these require electrical power. They basically have a digital control system in there, a little computer that regulates the temperature very carefully, has a built-in thermostat, air circulation system, and makes them a whole lot more efficient. There are no dangerous hot surface on it. And the amount of savings on this was dramatic, actually. We were saving about $80 a day. And despite the extra costs, it basically paid back in 2 weeks of use on the site. So this is one example. I'm sure there are others out there, and this is definitely the way to go if you've got to have heaters in your camps in these remote sites.
John, was that $80 per day?
$80 a day in total, I think, for that. Well, for one of those, yeah. So there's a lot of advantages of using these battery systems, and that enables the use of these high-efficiency heaters. You can use them when your generator is down, when it needs to be serviced, obviously. And then one big one you don't think about is it allows you to shut off that generator for long periods of time. And instead of having that noisy generator in the background all the time, it can be shut off and actually helps people sleep, especially the night shift on the drill who are trying to sleep during the day. There's other noise in the camp. If you can get that generator shut off for 5 to 10 hours, it really allows for a more peaceful camp and better sleep and better health for your workers there. So, and another thing is the solar panels can keep the battery system charged while you're not in camp if you're abandoning it for a period of time between programs. And by installing this whole system, you get people, everybody that works there starts thinking more about energy efficiency and how they can make a difference too, and builds that further into the culture of the company. Okay, come on. Here we go. Now, wind energy, while we didn't have a wind turbine there generating power for the camp, we did install a tower for test purposes to gather information on it so that we would have that information to consider for the future. And that was a joint venture, actually, where we partnered with the Yellowknives Dene First Nation and the government of Northwest Territories to help pay for the cost of installation. And while we were there doing our exploration programs, the senior geologist and camp manager was out there on a regular basis collecting the data, so that during this whole program we were collecting the data that we needed to really study carefully whether wind would be a practical solution in the future should we take this project forward into the mine development stage. So that's another thing that you can do now in exploration, is instead of thinking about after you've got the mine up and running how you can make it more efficient, start doing that, collecting that data during your exploration program, so that you can then start to factor that into the whole development plan for the mine and have renewables part of that development plan right from day one. And in this case, we were able to show that a 500 kilowatt turbine in this area could supply about 15 to 30% of the ultimate mine power demand at a substantial savings and total reduction of mine power costs. Oh, there we go. So in conclusion then, what we're seeing is great potential for energy efficiency to be used in exploration. And while the main motivation for it has been significant savings on your own overall costs in that camp, obviously it will reduce carbon intensity too by reducing your diesel fuel consumption. And in this new world of carbon pricing going forward, carbon taxes, that's going to become more and more important. So every little bit you can do to reduce carbon intensity is going to become more important going forward. Fortunately, there's more and more low-cost systems that are becoming available that can be tailored for individual camp circumstances depending on the size and longevity of that camp. You can find something that would be suited for that particular camp circumstance. And as I've said, I think the big advantage is if it's a company that intends to build something at the end of the day, then there's a lot of value in creating that culture to encourage early adoption of renewables and energy efficiency early in the mining cycle and try to maintain that throughout that mining cycle. You can generate a lot of the ideas, collect a lot of the data you need to figure out how to best implement it when you do get to production. And then you can start thinking about these same things on other projects that you're working on. And I mentioned our Separation Rapids lithium project early on. That's one that we're now putting more emphasis on. For obvious reasons, lithium is in high demand these days. It's actually situated on a river that has been used for hydropower generation already, and we are now looking at the early exploration stage on how we could use run-of-river hydropower there as another alternative on renewables to provide for our power needs there going forward, perhaps supplemented with renewables and reduce our reliance on diesel fuel. So there you have it, an example from the exploration side, and thank you very much for your attention here today.